Hello everyone, hello students, this is your Vignesh from your Mr. Vignesh tutorial. So welcome back to my channel. So in our previous class we discussed about physics. In physics we discussed about the unit called as force, work, energy and power. So in that lecture I think we have discussed up to momentum. We discussed the definition of the force, we derived the formula of F equal to ma, and we discussed what is momentum. So in brief I'll tell you once again. Momentum is nothing but the product of mass and velocity, and force is nothing but the rate of change of momentum. From that we have derived a formula, and from that we have derived a formula called F equal to ma, where a is the acceleration, and for gravitational force acceleration is equal to g, which is equal to 9.8. So F equal to mg, that is also called as weight of an object. Now in this video we are going to discuss about, I think this is our lecture 2 of unit 2. Okay, unit 2 we have lecture 2. So I told you already the quantities force, work, energy and power. So about work, energy and power we'll discuss in the further classes. So as of now we'll discuss about what is force and all. I already gave the definition. F is equal to d by dt of p, that is nothing but mass into acceleration, and for gravitational force it is equal to mg, which is also equal to weight. Okay, and p equal to mv, we already know. So I'll tell you some basic things about force, and I'll tell you about pressure also in this video. So pressure is our topic name now. So pressure is nothing but the force applied per unit area is called pressure. What do you mean by pressure? Now in general we tell, no, he's applying lot of pressure on me, or like in software field, like they tell manager or HR is giving lot of pressure to me for workload. They'll tell, no, that pressure is nothing but, in general there is not like mathematical formula, but mathematical or physics formula is pressure applied is nothing but force applied per unit area on an object. Like for example, there is an object, okay, let's say it's a plank. Now pressure is applied by a hammer, let's say this is a hammer. Now how much area, the surface area, how much on which the pressure is applied, that means the force is applied. This is nothing but applied area. This rectangular part is applied area, and this force, whatever force is applied, let's say 100 Newton, and I didn't mention you what is the unit of the force, right? And Newton and unit of force, right? Unit and dimensions. First, before going to this, after telling this, I'll tell you what is the unit and dimensions of force. So it is 100 Newton. Let's say its area is, let's say 100 meter square. Let's say. So pressure equal to force by unit area. So force is 100 Newton per 100 meter square. So it is equal to 1 Newton per meter square. And here you can see the unit of the pressure is Newton per meter square. Before telling unit of pressure, I'll tell you unit of force. Now unit of force, what is that? Force is equal to mass into acceleration, right? That is nothing but mass into acceleration is rate of change of velocity. That means dv by dt, right? That means change in velocity is also velocity only. Okay, delta v. Change in time is also time only. So we have for mass we have standard unit as kg, and for velocity we have meter per second, and for time we have time t. Got it? So kg meter time is second, second. So kg meter per second square is unit, and we have simplified this with Newton, because force is a quantity which was first discovered by the scientist named as Newton. The scientist called as Newton named this quantity as force. There is a small story, let me tell you in brief. We all know, once upon a time, long ago, there was a great scientist. He sat under a apple tree. Actually that was another tree. Actually thing is, it was known outside as an apple tree. So one apple got fall down. So then he wrote that gravitational things and all, he defined the force. From there Sir Isaac Newton coined the term called force. So the unit of that is given as Newton as a honor of him for his award, for his work, and Nobel Prize also given. So that is the unit of that, and its dimensional formula is this one, kg meter or units are this one, kg meter per second, and dimensional formula also you can get from that. For units and dimension I will create one more video, there you can know. So pressure is nothing but Newton per meter square. This is a unit of pressure, that is a unit of force. So I hope it is clear till pressure and force and its unit and the amount of quantities how you can take and what is the formulas for respective things. Okay, so now you can note down this, capture it or screenshot it, whatever. Okay, it's very important. Okay, so now we completed what is pressure, what is force. Now let me tell you some examples. Let me give you some examples. Let me tell you about free body diagram. First of all, I will tell you what is free body diagram. Free body diagram. What do you mean by free body diagram? The body is in free state on which some external forces are added or applied, and it has to be reacted accordingly. That means it has to be taken that forces, and what is the consequences we are going to see. Let's say there is an object of mass m. Okay, let's say it is in the air. How can it be in the air? Means we are throwing or something. For instance, it is at a height h from the ground. Okay, it is at a height h from the ground. This is the surface, let's say, or ground. Now wind force is applied on the mass in this direction. Okay, and let's say an external body, okay, F external is applied on the body in this direction, and let's say gravitational pull is in this direction, Fg, or weight which is equal to mg is in this direction, and let's say that this is wind force, this is external force, that means we are applying that force, and let's say some other force. What is that some other force? What force will take? The force which has to push it upwards. Which force? Let's say there is a gas, okay, some, or let's say some, there is a what we say, let's say there is a spring force. Okay, let's say there is a spring is pushing, let's say. Okay, so let's say Fs. Now all different types of forces are acting on it. No, now this is called as free body diagram. That means you have to show what all the applied forces are there on the object at a particular instant with directions as well, and if possible mention their magnitudes with units respectively. Now with magnitudes and units I will tell. This is a basic definition of a free body diagram and with clear explanation. Now I will tell you an example. Let me tell you an example. Now same mass of an object m, okay, gravitational force Fg or W is equal to, let's say, 100 Newton is acting downwards, and let's say spring force which is equal to k into theta, some formula will be there for spring force. So that is applying as 50 Newton, let's say, and wind force is applied as 20 Newton, let's say, and external force is, let's say, 200 Newton. Now in which direction it has to move? Now let's see horizontally and vertically. Let's see F total bar, its force is a vector quantity, is sum of Fx bar and Fy bar. What is Fx? What is Fy? Fx is the net force exerted in horizontal direction, and Fy is net force exerted on the object in vertical direction. Got it? Now Fx would be like in this horizontal direction. So as external force is greater than the applied wind force, so net force of X is nothing but F external minus F wind. So F external is 200 Newton and F wind is 20 Newton. So we get 180 Newton. Now 180 Newton is applied in this direction because 20 Newton and 20 Newton from here both gets cancelled. Extra 180 Newton is applied on the object in this direction. So resultant Fx would be 180 Newton in this direction. In that direction 180 Newton will be resultant, that is Fx. Now let's see Fy. So you can clearly see that 100 minus 50 is 50. 50 will be coming downwards. So Fy equal to 100 minus 50, that is equal to 50 Newton. 50 Newton in downward direction. Okay. So now let me tell you the simpler form. Let me tell you the free body diagram in a simpler form. So we are simplifying that. So we are getting resultant force Fx which is equal to 180 Newton and we are getting a Fy which is equal to 50 Newton. Now the object will move in which direction? So we have to find a resultant of this. It may move in some particular direction like this. So we have to check. How to check that? F net is equal to root over Fx square magnitude plus Fy square. You get the magnitude of the force and you have to draw a triangle. Let's say this will be Fy, this will be Fx. So you have to find angle from that. That is nothing but theta, tan theta, or theta equal to tan inverse of Fy by Fx. That is Fy is 50, Fx is 180. You get theta from here, so that you get direction of that force along which direction it's going, and you get magnitude from here. So these are the formulas. F net equal to root over Fx square plus Fy square. This is the magnitude of the resultant force. Theta equal to tan inverse of Fy. Let me tell you, Fy by Fx here. So this is the formula for angle. So you get the direction, you get the resultant force magnitude as well. So this is how you are going to do any problem on which they are asking about force, net force on an object. So this is what about our net force on an object, pressure, units, dimensions, formulas, basic free body diagram with an example. So any kind of doubts, please mention in the comment box. I would love to solve them as soon as possible, and I will always be available with you. So mention me what extra I can teach you and what and where you have doubt. So mention in the comment box. I will always be reachable. So please take a screenshot of it. It's very important. And like, comment, share my videos, and please subscribe. Don't forget to click on the bell icon. Until then, this is your Vignesh from your Mr. Vignesh Tutorial signing off. Bye.